Do you feel like it takes very long for teams to develop high-quality data products, especially in large organizations? Do you wonder if GenAI agent can help? My short answer is yes. Today, I'm going to show you how to use Strands agents to develop data products under 30 minutes. In large companies, it is quite often to take many months to develop data products. From requirement gathering to sending to the analyst team to do initial data analysis and build data model. After that, they need to hand the data model to the data engineering team to develop the code. After the data engineering team runs through the code and have the data product ready, they will need to have it sent to the quality assurance team. This whole flow takes a lot of communication back and forth. Agent here can help. Let's first see this problem set up. To mimic a scenario, I have 4 CSV files sitting on my computer. In reality, these should be coming from 4 data sources. I have an investor file, which contains basic investor information with investor ID, their names, and the date. And I have their portfolio information, that's their internal database with every investor's stock and what's their holdings. I also have a stock profiles, that's just basic information about the stock, what's their symbol, what's the sector. I also have their transactions. This is going to be a huge data set in reality because it has for every investor's, every stock transaction, what is the transaction date, what's the quantity and price they transactioned it on. So following data modeling design best practice, the data modeler team will want to design the investor and stock as a type 2 slow change dimension. And I will want to see a transaction and portfolio to be designed as type 1 fact tables. And all these 4 tables need to have a proper surrogate key to link them. Right now they only have the natural key. Right, that's my expectation. I will first show you what Strand agent can do, and then we'll go back to see how we did it. So I set up my Strand agent, and I gave it a very simple instruction saying design a data model for this data product that will be used by the fund sales analytics team. And then after that, build the data product. The source data folder is stored here, and I want to see the output data model to be saved, and the code be saved, and the final data product to be saved. When I launch the agent, you're first going to design the data model. And when they start to design the data model, it's calling a CSV extraction tool. It ran into a little error, but that's okay. I found out it's timed out, but let's try it again. And this time it succeeded and extracted the schema and then designed the data model and saved it out. And let's take a look at that saved data model, see if it's good. So it gave me 2 data models for data model summaries. One is at the table level, so I'm pretty happy with this. So it first gave me here's some basic information, and then it tell me here's some fact tables, and there's a transaction fact table and the portfolio fact table. And it's smart enough to tell me what the granularity should be. And that's good. And then it gave me some dimension tables. So first it gave me the investor dimension. That's good. I need it to be a type 2 slow change dimension to keep track of all the historic changes on every investor, their marital status change, their address change. That's just for regulation purpose. And then it gave me a stock table, also type 2 slow change dimension. It's also smart enough to create a date dimension. I didn't ask for that, but it knows that if there's a date dimension, it makes the connection of these tables very easy. Okay, cool. That's at the table level. And it also need to give me the fields at the data model at the field level. So this is a source to target field mapping where the data engineering team can take and develop the final data product. So it will tell me this is the target table name, the target field name, and their data types. And it will tell me the source field. This is interesting. Some of these sources are directly copied from the source table. Some of them were generated, like this one, it generated the primary key. And then these ones are good. They generated these date columns and the current status column, and these are used for the type 2 slow change dimension. Good, so dimension table is good. Let's take a look at the fact table. Let's take a look at transaction. Transaction table, first it generated my primary key, that's good. And then it knows that they need to pull in these surrogate keys from the dimension tables to stamp on my fact table so that I can link them. Okay, and then there are additional information to pull in. Okay, this looks good. And the agent started to generate the code based on the data model. And the code generation is very long. And I purposefully have the code generation and code execution set up in two sub-agents to ensure that it generates all the high-quality modularized code and then execute. If you have it goes together, sometimes the agent will just generate scripting code and then execute and then move on to the next part of the code. The code goes through, and in the end, it was pretty happy and gave me, this is very long, in the end gave me, the tables are saved. Good. Let's take a look at the final results, see if we're happy with that. Okay, I got my data product. I got all the dimensions and the fact table. So let's pick one dimension to take a look. Okay, my investors, good. I got my investor key, not just IDs. And then I got my start date, end date, and it's current or not. In the real database, this will be more interesting because you'll have some outdated records that have a real expiration date. Right now, these are just dummies because nothing has expired yet. And then you will see some record is not current anymore, and that investor probably have a current record that's live. Okay, so the investor, that's good. And then let's take a look at the fact table. Okay, so my transaction fact table looks good too. And I'm pretty happy that it stamped these keys on my fact table. I have my investor key and stock key. Now when I join these two tables, I can just directly link my investor key to my fact transaction table. I don't need to worry about find out the date range, whether this transaction happened at this customer's which time range. That's good. I'm really happy. And Strand agent is really strong at having the development team put in what they know the best, which is what's the existing human process, how do we prompt it, how to teach the agent to do the work that human used to do. And it largely minimized the effort to set up the agent. Let's take a look at the code. So behind the notebook, this is the main workflow function that I called. Because these sub-agents are obviously working through a flow, you need to have data modeler first, and then have the data engineer, and then have the code runner to execute the code. So I just set it up as a workflow. That's one typical type of agents. In some other scenarios, you can have multiple agents and have them collaborate, basically swarm together to solve one problem. In that case, you don't need to define a typical flow. Or you can define the graph. Here are a few sub-agent paths that you can take. Don't go the other ways. That's a more dictated way. So in my case, it's simpler, just a workflow, 3 agents, go through 3 steps. That's it. And you can see in my file, there are only 3 files I imported that I need to define. The first is the large language models. I happen to define a few because when I was building it, I was experimenting what's the cheapest way, what's the simplest model to get it done. So we defined the data model, defined models. It's just calling the Bedrock model from Strands models module. So model need to be defined. And then after that, I need to define the prompts. And that is where user can put in all their knowledge and the instruction into the agents. So I have For data modeler, I need to give it instructions, say that you're a data modeler, you need to follow the data modeling best practice and extract schema to know the source data, identify the facts, dimensions, establish relationships. And then I will give it instruction on how I want the output to look like. And this will largely enhance the quality of the agents, the accuracy of the agents. Similarly, I define the prompts for my data engineer. How you write the code, modularize it, and when it's type 2 slow change dimension, watch out for these things. And I also have a small prompt for my code runner. So that's it for the code, for the prompts. And the last thing I have to define is the toolkit. And if you notice these agents, each agent will have a few tools. Actually, a large part of the agent's performance is dependent on the tools. It's like you and me. If you have a easy to use tool, it will enhance your productivity. So in this example, all the tools I defined myself, but for Strand agents, you can define it or you can call MCP very easily. So these tools I defined, I put them in the toolkit, and the definition of the tool, just the Python functions, and then you can use the tool decorator from Strand agents to convert it to a Strands tool. And that's it. That's how I build these agents. So the most effort just goes into defining the prompts and defining the tools. I would like to encourage you to think about what are the processes or daily routine work that you want to automate, and take a look at Strands website and try out building some agent yourself.